AP Chemistry, Unit 6.7, Bond Enthalpies. In a chemical reaction, bonds are broken and new bonds are formed. And when bonds are broken, energy must be added to the system in an endothermic process. And when bonds are formed, energy must be released in an exothermic process. The enthalpy of the reaction, or overall change in energy during a reaction, can be estimated by adding all of the energy needed to break each of the reactant's bonds, along with all of the energy released from the formation of new bonds in the products. This will be given in the unit kilojoules per mole. So we have the overall approximation equation as the overall change in enthalpy, delta H, is going to be equal to the energy that is taken in to break the bonds of our reactants and the energy released from our formation of new bonds. So if we were to look at an example where we are reacting hydrogen and chlorine to produce hydrogen chloride, and we had each of the bond enthalpies of each of the bonds that are important for this reaction here. So we have the hydrogen to hydrogen bond given as 432 kilojoules per mole. The hydrogen to chlorine bond has a bond enthalpy of 427 kilojoules per mole, and the chlorine-chlorine bond has a bond enthalpy of 243 kilojoules per mole. So we will separate it into bonds broken and bonds formed. So we have overall the hydrogen-hydrogen bond being broken, thus I needed to add 432 kilojoules per mole amount of energy into the system in order to break apart those bonds. The chlorine-chlorine bond must be broken, so I had to add to the system 243 kilojoules per mole energy to the system. And then for my formation of bonds, I am forming the hydrogen chloride bond, which is going to release energy. So whereas I had to put in energy and thus my enthalpies are positive for my bonds broken, for my bonds formed, I am releasing that energy as I form my bonds. And since in the balanced chemical equation there are two hydrogen chlorides here, I have two hydrogen chlorides, and so thus I have two bonds between hydrogen and chlorine, and so I will multiply the overall bond enthalpy of the hydrogen chloride bond, which is 427, by 2, since I have two of them. And again, since the energy is released, it will be negative 852 kilojoules per mole. And so I will add all of those together. So I will have positive enthalpies from breaking apart my reactants bonds. And then I will have a negative enthalpy from me releasing the energy as I formed new bonds. So we are adding everything together. However, remember that this is releasing energy, and so it is going to be negative. So I kept the positive there to make it clear that we were still adding all of the enthalpies of our broken bonds and our formed bonds. But just to be clear, this is still negative. Once I added all of those together, I end up with a negative overall delta H, negative overall enthalpy of 179 kilojoules per mole. And since I have a lower enthalpy than I started with, I am negative 179 kilojoules per mole. I am going to be overall exothermic in this reaction. I have released more energy than it took for me to actually go ahead and put in to break those bonds. So I am exothermic.